It is a warm spring afternoon, and you would like to ride your bike to enjoy the sunny nice day. You want to check the tire air to ensure you have the correct pressure. However, you found you don't have the pressure gauge with you. Is it nice if your smartphone could display your bike tire pressure whenever you want? So you have drive your car to work. When the flat tire indicator lights up on the dashboard, you pull over to investigate. But all the tires look the same. Would it be sneak if you could use nothing more than your smartphone to quickly tell which tire has lower pressure? We propose a non-contact tire pressure reader use a smartphone based on our pattern of visible light to camera communication. A small pressure sensor in the tire valve cap has an LED that brings to transmit encode information about its measurements, which the smartphone's camera then receives and decodes. The product is a small pressure sensor for tires, built with the SigLamp's EMF8 SleepyB microcontroller, which is a perfect match for this application thanks to its low cost, small form factor, and ultra low power consumption. Due to the small mm by 3 mm size of the MCU, the entire circuit, including small pressure sensor and the tiny watch battery, can be embedded in a tire valve cap. The MCU ultra low power consumption allows the device to run for years without needing to change the tiny watch battery. The MCU's built-in rich analog peripheral can easily interface with a pressure sensor, and the on-chip temperature sensor can be used to collect the air temperature. The high current sink capability of GPIO pins can directly drive the LEDs. The pressure sensor embedded in the tire cap looks almost identical to a regular tire cap, but there is a tiny LED in the top of the cap. Inside, the SleepyB microcontroller, the air pressure sensor, and the operation amplifier for conditioning the pressure sensor output and the battery are packed as shown in this cross-section of the cap. To check the pressure, simply press down the cap. A mechanical pin pushes the air pressure valve down slightly, release a small amount of air into the sealed cap internal space. The press also triggers the microcontroller to power on the pressure sensor circuit and to sample the air pressure. After releasing the cap, the LED starts blinking, transmitting the encoded pressure data, temperature information, and the clock reference. Now just point the smartphone's camera at the blinking LED. The app uses the camera to sample the light transmission frame by frame and immediately decodes and displays the tire pressure with the temperature correction. The smartphone can then query a cloud service for additional useful info, such as the recommended pressure for the type of tire, and even the history of the user's tire pressure reading to calculate the leaking rate. By the LED camera interface, the pressure sensor is able to connect to IoT network. The device is super convenient, and the point and shoot operation is simple and easy. The entire circuit is a very low cost, under $2 or $3, and the smartphone app is free. We hope this device can make your life easier.